Cool. How's everything on homework? 3? Good. We can get into it later. Um, yeah, I mean, there's a office hours you could book, or after class we could chat. But feel free to let me know if you need help. Anyway, homework 3 will be due today at 11:59. Hopefully the first one shouldn't be too tricky. The second one likely will be a lot more trickier than the first one, because you would need to look into one of the most confusing and um concept of class and object in programming languages. So don't feel frustrated if you couldn't get it right the first time. Um, Everyone who's into, objective-oriented programming will get stuck on class and object at some point, especially the first time you encounter that. Cool. And there's also homework 4, which is already online. You can find it on the course website. Mm. Um, I believe I would talk a little bit about homework 4, but this is it. Basically, when this is what you're given, like a spectrum visualizer. You will use the FFT. If you run the template sketch, um, pretty much what you will get is these two things. When you are talking, it will look like this. When you are singing, you will see all those spikes that's, evenly distributed. Where are all the markers? They are all gone. Okay, no markers staying. Um, anyway, these are, speaking, these are spectrum for singing. And you see the difference is that these are evenly placed spikes. These are, just random stuff. Anyway, what you want to do is just to do some array manipulation, or just visualization mostly. You want to turn this and try to visualize it better so that it won't show the full range of that. The full range can be different, depends on what's the sampling rate for. Oh, I saw the markers. What's the sampling rate of your microphone? So in my case, my microphone is 48 kHz. So, at this point, it will be 24 kHz at this point. So, there will be a lot of things that just doesn't see any activation. So you want to try your best to map it into something, with a lower highest frequency so that you can see better all the spectrum. So it depends on the sampling rate for your laptop microphone. So, just adjust as you wish. But basically, you want to, see more easily the peaks and the spectrum. And you also want to implement this trace thing, which is commonly seen in some of the spectrum visualizer. The idea is, the hint is that you will just have an array that store this maximum value, and it will just slowly going down. And whenever there's something, higher than that, you want to replace the value back to the highest activation. So if there's something lower than that, it will just keep dropping. So the idea is that, you will have a separate array to keep track of the maximum, trace. Cool. If you want to know more about Fourier transform, at the bottom of this page, there's a very nice, video talking about what Fourier transform is. But for our case, just stare at it and get a sense what it is. That's pretty much good enough. Cool. Any question on homework 3 or homework 4? Yeah, definitely look into it as soon as possible because we will also have the midterm assignment coming up and they will likely be due pretty much at the same week. Cool. Just some recap. We were talking about array versus list 2 weeks ago. So array and list, they're pretty much similar in the sense how you work with them. So the difference is that, for array, you have to declare for a specific size. So array is fixed size, list can be dynamic size, but there's also some benefit about array where it could be much faster and, it's much easier to work with array. Most of the syntax is much easier. But, initialization, you could 0, 1, 2 directly with the array. But for list, you have to do some functions like append or, add. For length, for array, you just do .length without the parenthesis because this is the property of an array. But for list, you want to look at the size parenthesis because it's a function of a list. A list doesn't necessarily know how long the list is. It has to trace it so that you get the list, the length. But anyway, you can still pretty much do the same thing for array and list. And we talk about, sorting an array and sorting a list can be different in that, sorting an array usually will returns a new sorted array. But for list, it usually just returns the original list. I mean, in this case, it's not usually, it's always. But for other functions, usually the default behavior is that for array, when you do something on the array, you will get something new. That's what we call non in place. When you do something on list, usually it will be in place so that it will be the original one, just, sorted, reversed, modified rather than something totally new. We talk about a little bit about, the difference between array and list. For our class, usually either is good enough. But the biggest difference is the size will be fixed and list will be dynamic. And the speed, array will be slightly faster, list will be slightly slower, different things. But in this case, in our class, likely you won't be doing something big enough. You see noticeable differences. And lastly, we talk about this library manager in processing, where you can download all the external or internal libraries, official libraries, I mean. Cool. Okay, so last time we didn't really look into these. We just rushed through the cool. So again, the biggest, the most important library we'll be looking into is the sound library. So this library is basically a bunch of classes and functions that you can work with sound. So this will be important for homework 4, but also your midterm assignment because likely you are, working with sounds. Either that's, internal sounds, some file you read from an audio file, or, you can directly just use the microphone like you will be doing in homework 4. So in this case, IO sound file, audio sample, audio in. So sound file will be, when you are reading an audio file like MP3 waveform, audio in will be the microphone input. You can do analysis, you could analyze the amplitude, beat, you can track the beat, you can do pitch detector. Those are all built-in, not the best performing one, but good enough. You can get the waveform, you can also do FFT. That's what we see in homework 4. You can do all sort of effects, depends on what you like. These are just like very simple effects. And if you want to do some cool tricks changing the sound rather than just use it as it is, You can also do noises. So by noises and effects, you can actually build some simple synthesizers. Say, you know, all sort of different synthesizer. You can do, low pass, band pass noises so that you can do that subtractive synthesis if you like. Oscillators. So now oscillators, noises, effects, you can actually even do, additive synthesis, FN synthesis. I don't know whether it's possible, but likely you can do something like that. There's also some other stuff. Anyway, all the documentation can be found on the website. So we will look into some of the example. I didn't actually check whether they're still working. Let's see. Hopefully they are. Let me find those photos. Temperature. Okay. So in this case, well, while it's still opening, what you will see is that you will initialize an amplitude object. So this amplitude object is an object, obviously, and you will, initialize an audio in object. So the audio in object is something that will just work with your microphone, and the amplitude object will be something that can be applied on top of an audio input so that it can analyze the amplitude. So what's going on here is that now in is the microphone. So this is the microphone. You start the microphone, and then you put the microphone as the thing that you put into this amplitude dot input. So this will just route the audio input to the amplitude meter. So think about amplitude meter is like an object, like a factory somewhere there. And you have the audio input, that's the microphone, and you route the microphone output into the factory. And that factory will just analyze it whenever you code this amp.analyze. So that's it, basically. So now you have the amplitude of amp.analyze. So amp.analyze, what will you analyze? That will be the amp.input. So that will be the microphone input. So the microphone input will be analyzed by this amplitude meter that you initialize, and you get an A, which is the numbers of the amplitude. And then, this amplitude will be normalized to 0 and 1. So you basically times 400 so that you see they shaped. Now I will try to see if this works. I didn't test, so hopefully, it's not bad. So this is I'm talking, and you can see that it's actually just showing the amplitude of the sound. So, this is a very basic way of doing stuff. So this is doing the microphone input. You can also have another file. You can also use that's you can also, open an audio file to do it. And somehow it's not showing up. Let me see. Okay, cool. Cool. So this is another case. This is a little different because now if you look at the code, now we have this amplitude the same. Now it's a little different because now we are doing this sound file. So this file will open up this specific amplitude file, and now you do file.play. But pretty much that's the same. Other than that, you just send the same thing, once it stops playing, you do amp.input file. So now this amplitude meter will be analyzed in this file, and the rest is the same. You do amplitude.analysis in each single frame, and you map that number times 400 so that you get the output. Okay. Oh, somehow I don't. Okay, cool. So that's the idea. You know, this is just a very tiny example, minimum working example for you. But you can imagine, you could do all sort of other things so that, there's something responding to the amplitude of the sound. You can also do pitch detector. Again, this is like a very simple way just to show how things could work. But you could also map it, not just as a line. You could map it to something else. But this is just to showcase, you know, how things work. Let me see if I can find the pitch detector. Oh. Cool. So this is the pitch detector. We should just let it run. We just keep it playing, I guess. So the idea here is sort of similar to how we have the amplitude meter. Now we have this pitch detector. So what you want to do is that you initialize the pitch detector object, just like how you initialize an amplitude meter. So now you have this audio in, which initialize an audio in object. So pretty much the same. So now you want to do in the start. So now you start taking audio input. This is the microphone case, which will be different from what we are hearing right now. Can I stop it? So this case is where we are using our microphone input. So let me open that up. But basically, once you have the input started, you can route it into the pitch detector. So PD.input in. Now you just want to analyze the pitch. And the 0.5 is the sensitivity. So it's somewhere 0 to 1. So you want to set the sensitivity. So in this case, we just put 0.5. So if there's a pitch, so this sensitivity basically will show you. So the idea is that sometimes it could be silent, sometimes it could be, there's a pitch. So this sensitivity will just set that threshold whether there's a sound, a pitched sound. So if pitch larger than 0, if there's no pitch, the output would be 0. If there's a pitch, the output would just be that the hertz, the frequency. And if there's some pitch, then you just show the red line. Basically, that's the idea. So you can see in this case, now it will be taking my sound. So you can see a pitch. So you see that, it could be different pitch. Anyway, so that's, the amplitude class, pitch detector class. There's also beat detector class you can explore, which is a little bit different from these two. But basically, we also have the most complex one, I guess, FFT class. So now FFT class is that, input some sound library, the same idea. Now you initialize an FFT object, initialize an audio in object, which will take the microphone input. Now a little bit trickier. Now you want to initialize an array to store the spectrum. This is essentially what you get for homework for the skeleton code. So in the start, you start taking audio input, route the audio input to the FFT analyzer. So now it's a little tricky. FFT.analysis analyze spectrum. So this spectrum is an array that you put into, then FFT will compute the inputs as in, and it will store the outputs to this specific array that you have put into. So it's working a little bit different from the amplitude one, because amplitude one, you will just basically do A equal FFT.analysis, analyze. So in this case, you have a spectrum that's predefined array. Then you put it here, it will update the array numbers in place. And then you just want to showcase all the outputs. We could also have a short demo. This is okay. For homework 4, you will see the one with microphone. This is the one with a specific file. There's actually some sounds going on. So it's actually Twinkle Twinkle Little Star. So you see all the evenly placed spikes. So those spikes are, think about. So these could be, 440 hertz. Then this will be 880 hertz. This will be, whoa, that's the artifact of playing. So these are like F0. So this is the fundamental frequency when we talk about the frequency of a pitch. And this will be all those, harmonics. So everything beyond the fundamental, we will call it harmonics. And the ratio between these different harmonics will determine the timbre. And that's why, for piano, for guitar, for bass, they all have the same pitch for, C0. But why do that sound differently? That's because the ratio between F0 and 2F0, 3F0, 4-0 could be in different shape. So, it could also be something like this, everything kind of similar in in amplitude. And for this case, it's much quickly decay for higher harmonics. So the ratios or the distribution between all these different harmonics will determine the timbre of a sound. So that's why it's interesting for looking at FFT, because you see this is basically the spectrum of I'm singing. So everybody has a different timbre, or all the instrument will have a different timbre, then you will see differently. Cool. So anyway, that's FFT. You will have to work with it anyway in Power 4. So this is basically what you will get for the skeleton code. So you will just work on from this. And what you want to do is to work on the spectrum so that you can turn the spectrum into something more easily observed. So in this case, because the pitch range is too large, pretty much you're wasting the whole, pretty much 70% of those are empty. So you want to better leverage the x-axis. So you want to map it. So you want to do some array computation, manipulation, basically just visualizing part of the array rather than the whole array. You also want to implement this trace thing. with another array. Cool. Other than that, the skeleton code should give you a very good starting point, and then you just improvise on top of that. Cool. So we've just covered that FFT class. That's pretty much it. Cool. Questions on this? Yeah, again, you have to download the sound library in case you couldn't get it work. Cool. So today we are actually looking into images and videos. Let me grab the slides. Okay, cool. So this is a class in music school, so we will be audio first, but to be honest, processing is more about images and videos. So now we going back to images and videos. How we can, load images and videos and work with those. So, we talk about how we can work with sound. And in processing, there's a lot more about, images and video processing. So for images, we've already talked about this class and object thing. So now, we can better work with images. So basically, images are handled by a specific class in processing. So it's called p-image. So usually in processing, built-in classes usually started with a p. So that would be processing image. So p-image is basically just a special class for image in processing. So this is a class for storing images. Processing natively supports a bunch of different formats. Should be good enough. GIF, JPG, JPEG, and PNG are both all supported. Something else, you could also try to make it work with external libraries. And we usually create it by loading an image using load image, we will see later. But you may also create a new image from scratch using create image. So these are the two functions for creation. And once you get the p-image class, there are three things that you can get, width and height, obviously what those are, and pixels. And look at the, this bracket, meaning that it's an array. So this is very tricky because this is actually a 1D array. So, image is definitely not 1D most of the case. It's a 2D thing, but the internal pixels are actually stored in 1D array. So we'll see. So this is like the first example. What we can do, we could just load image and, say in this case, image, the load image, pull the JPEG. So, now you load the image. And so you can pretty much treat image as a rectangle. So, previously we were talking about how you can, draw a rectangle. So you do rect, some x 200 200 x y, and then the size, I don't know, 100 100, so that you get a rectangle. So pretty much you do the same thing for image. So now you have the image, that's a big image. Then you can set, image mode center. Now what you can do is like three different ways. So image 100 100 would be the center point, and then the size will be 200 200. So 200 200. And for the second one will be 300 100. So 300 100, and the size will be half the size. You can even stretch it into 350. So now it becomes 1:6 ratio. So basically you can just treat image as a rectangle. In this case, what you want to do is that, you code this function called image. So it's pretty much like rectangle, just that now it's image, and the syntax will be the essential image that you have here, and then X, Y, width, and height. Cool. So that's the simplest way to do it. But pretty much you load the image is not just about, just this display in it. So one thing interesting about images in processing is that you can actually work with those pixels and you can manipulate those pixels. That's why it's interesting. So we can actually interact with the pixel image. So as we said, image the pixels, you get all the pixels. That's the field of that class. So those are some of the variables stored in that class. Now you can do image that load pixels. So this thing will load, you have an image. Now you want to turn this image into the pixels array. So this will be automatically called when you have the image set up. Now you can also have update pixels. Now you can actually change things inside this pixel array, and then you do update pixels so that the image will be show up like that. So this is a bit tricky, but we can see it in some example. So the idea here is that we want to modify image.pixels directly. So we want to add the small red box at the bottom, right? So how can we do that? So one way we can look into the whole idea. So now we have the image.load image.pull.jpg. So let's go back previously. So previously, this is image.load image pull.jpg, and then you just do everything about image, blah, blah, blah. So you are not actually working with that pixel array. So now we are looking into how we can work with that pixel array. So the first thing, you load the image as it is. Now you want to do this load pixels. So load the image content to pixels. So the whole idea here is that the actual image that you have, I don't know, something like this. The actual image that you have and the pixels array, this is the image.pixels array. They are not, always automatically synced. So you have to specifically code this thing so that it will sync. So originally you have some image, and now you call, load pixels. And this is when it started to, fill in these numbers. Cool. So once you code this load pixels, the whole image will be stored into this pixels array. And so now you can actually just do this manipulation. So what we want to do is at the bottom right, we want to turn it into red. So, if you look at this for loop, it's basically I equal image.width minus 50 to I image width. So there will be image width minus 50 to image width, and then image height minus 50 to image height. So basically these whole things, this is a double for loop. And so everything in between those would be FF0000. So FF0000 would be RGB. So R would be FF is the maximum value, 255. G will be 0, B will be 0. So this is just for red. So basically, this will update the pixels at the bottom right into red. So once you've done this, say, you do some stuff here, say everything else at the last few pixel will be 1. Now you update those. Then you want to turn it back so that you call update pixels. And then the pixel array will be updated back to the image. So, in processing is a bit tricky because these two things, it's not like you update the pixel array, it will be reflected from the image. These two things you have to, explicitly code low pixels and update pixels to work with those. But again, that's pretty much it. So you have an image, you can load pixels to the pixels, and you do update pixels to get to that. You can actually also just work directly with the processing window. So in this case, is that you have an image and you want to work with it by calling, image.load pixels, image.update pixels. One thing interesting about processing is that you can also do it without image.load pixels. Now it's just directly load pixels, update pixels. It will treat the whole processing canvas that you have as an image, and you can do all sort of the things we talk about. So now we can do something interesting. So this is the reveal effect. You can get the example image. Where is this? Let me see. I think I forgot to update it. So this likely is the last year's. Anyway, that's not too bad. So let me share the link to our chat. I think that's the easiest way. Where's our chat? Cool. So this is the link to an image, or you can just download whatever image you like online. But basically what you want to do is to see if you can do this by working with this. So the idea is that I don't know, think about actually with what we just talked about, we can implement this. Any idea how? We just talk about, we have an image. We can turn it into some pixel array. We can do low pixels to that. And then we can do update pixels with that. Now, we can also do the same with the whole canvas. We can do low pixels and update pixels. How can we do this kind of effects? Any thoughts? Yeah.
You have it drawn underneath, or you just do update pixels conditionally on array around states.
Yep. So yeah, that's basically the idea. But essentially, how do you decompose it into different steps? So what you need is that we need the the underlying image, right? So you will need to load this image that you want to store into some array, and that array will not be show on top of this. So the whole array will be black for the processing things. So you will have like two array. So you will load the image. So, some image, you will load this image into some image array. And then you will have the processing. This is the processing thing. And so this processing will also have an array. Some, I don't know, array. And basically this array will be all 0 at the beginning. And now this image array, once you do low pixel, it will be something other than 0 that will store the idea. So what you want to do is that now you have a mouse X and mouse Y for that particular region. You want to grab that particular region of those and then put it into this array. And once you put it into this array, you want to send it back to update the pixels. So think about how you can implement that. One thing you might find helpful is that you likely wanna do something this. So you can do something like this original. You can actually clone an array like that. It's actually not an array. Yeah, cool. Well, I think we can. Um, so the first thing try to do is that grab the image, try to show the image. That's where we can start. Let me see. Um, so for the image, you likely want to save it somewhere so that you have the image. So you can save these things. Let me just save it at download. And cool. So I save this thing in the temp folder. So this is where I save it. And now I can grab the image that we have. I've sent to the link. Cool. So now I save pool here. So now let's see how we can load this image. So void setup. Let me see. Void setup. Cool. So what we want to do now is that we want to initialize a p image um thing, and we want to load the p image. So what we can do is that image dot load image foo.jpg. So this should give us that image, and we can do the simplest thing that just show an image 0, 0, 400, 400. That should give us put image here. So this is the basic thing that we can do. We have a image that we load. Now we have the image. We just show the image as 0, 0, 400, 400. So 0, 0. Now we are not using the center mode. So that will be the top left corner. And the width will be 400. The height will be 400. So it will just completely, have occupied the whole, canvas. So what we can do now is that, we can have an integer array. This is the array that we want to store this image so that we can keep it, that later we can reveal it. So, this original thing that we want to actually copy that. So what we want to do is to do original dot equal to pixels dot clone with And then once we clone it, let's set the background to 0, 50 actually. Okay, let's see how it goes. Still there somehow. Low pixels. Let me see. Oh, I'm missing something here. Cool. Cool. So basically, this is what we want to do. Let me get it all done, and then I'll explain what's going on. So integer y equals 0, y less than 400, y plus plus. Do something here. So this is essentially what we want to do. So initially, you load an image, the PUI image, and then you load the pixels. So this will be the original. Oh, I think what's happening is here that we don't have this. This should be here. Nice. So what's going on here is that, you have a image, a PUI image, and then you show it, and then you load pixels so that now all the pixel will be stored into this pixel thing. Let me show it this way. Let me explain what's going on here. So you have an image. That's say this is the PUI image. This is the image thing. And the second thing, now we are at line 6. Now you have the image, you load something. Now you show it on the canvas. So now this is your canvas. This is your pixel, your processing windows. So now you show it here. So now you show the PUI image here with this number line 7. Now you do load pixels. So this will save this thing into the pixels array. As we talk about this pixels, when you didn't do image the pixels, this will be the global pixels array for your canvas, canvas window. So now you store the PUI image into this, pixel array, blah, blah, blah. Now you want to clone this thing because this is the original image that you want to keep it. So now, where's my, well, now you want to create another. So, in the beginning, we have this integer original array where, you basically clone everything here to the original array. So you want to keep the original, image in the original array. That will be a separate copy of this thing. So this is what's going on in this case. And now you do background 50. Now, sadly, this thing will be covered by the background 50. So everything will be gone. So, no more PUI image. Everything is gone. Now you do the second low pixels. So, even now everything is gone, this thing is still with the original PUI image. So now the second time you call the low pixels, everything will be deleted into this 50-50 0 thing. So we can actually see that by, not doing this low pixel, then you can see that it will be a different things. Let me see. Not here because we are not updating it. That's kind of awkward. Update pixels. Let's do it this way. So in this case, if we didn't do the second low pixels, so if we didn't do the second low pixels, we didn't remove the original things. So when you call the update pixels, it will actually grab the original pool images back to the processing thing. But now if you have this low pixels, how do I get rid of it? If you have this low pixels, we will do this update thing so that everything will be deleted. So now everything work as expected. Now everything will be black initially. So now the idea is that looking at this, how we can go beyond that and create that reveal effect. So that's what we should work on. Once we have this set up, pretty much everything else is just, pixel, manipulation. So what we get now is that we have an original array, which is the original put image. Now, basically, whenever we have something here, we just want to, grab, say, we have something here. This is mouse X, mouse Y. And we basically just want to clear things around it with the original array. So we want to copy the original array, whatever we have from the original array within this region to the new pixel array. So how can we do that? Any thought? Any thought? No thoughts? So basically now we have the pool image somewhere, and we have this like all black thing, and we have the pool image in the original array. And now we want to go through all the, pixels. And whenever we have a mouse X, mouse Y, if it's close enough to mouse X, mouse Y, we want to copy the pixel value from the original array to the new array. So that's essentially what we want to do. So, a way how we do it is that, look at what we have, mouse X and mouse Y. Essentially, what we are trying to do is that, we want to do an if-else. If the distance between mouse X and mouse Y to X and Y actually X and Y to mouse X and mouse Y. So, say our mouse X and mouse Y is here. Now this for loop is going through all the pixels. So whenever a pixel is so far away, we don't want it to be updated. So XY would be the cursor that you are scanning through this things. So whenever it's so far away, we don't want to do anything. But when you have the X and Y fall into this region, when X, Y, and the distance between mouse X and mouse Y and the current cursor X and Y, current cursor, and mouse X, mouse Y, the anchor that you have, is smaller than some threshold, that would be the size of, the size of your reveal effects size. Say, let's do 20 in this case. If this is the case, then we want to update the pixels. So pixels X, Y. We will get into this later. This doesn't work, but this is pretty much the idea. We want to update the pixels XY with the original array XY. So this is the tricky part comes in. So XY doesn't really work because pixel is again 1D array. So how we want to turn the things into a 2D array is that we would do X plus Y times width. So the idea is that, well, now we want to get this, XY point. This is XY, but this things is actually a 1D array. So they actually go through so many, Y times of width until you reach this X. So I guess the way to look at it is like this. So, you have an image that's, say, something like this. If you want to get this point, when you turn it into a 1D array, it will be 2 slices of horizontal stuff plus the actual x-axis. And so this will be 2 times, like 5 times y plus x. And this 5 will be determined by the width. So basically you want to do y times width plus x. So this is essentially it. Hopefully it works. Let's see. Cool. Oh, I think something weird is happening. Let's try again. I think we're close enough. What's going on? Likely something wrong here. X, Y plus width. Should I do Y times? Did I mess up with this thing? X plus Y, or maybe it's X times width plus Y. Let me see. I think we're close enough, actually. No. Let me see what's going on. X, Y. Looks right. Let me see what I have for. Did I miss anything? Oh, maybe that's the reason. This things might not be afloat. There's something weird happening. This seems like mouse X and mouse Y. Did I mess up with something? That's weird. Hmm. Well, I don't know what's going on. Let me see. Did I miss anything? 400, 400. Mouse X, mouse Y. Update pixel here. D smaller than 20. Hmm. Just the clone. Well, maybe see if I can find the original file. It should be correct. Kind of weird. Pixels reveal. Well, pretty much essentially the same. I don't know. Likely there's a typo somewhere that I couldn't see it right away. But this is pretty much the same. I don't know what's going on. Let me just copy paste to see if that's the case. Did I type something wrong? Same thing. Let me just run this file and see whether it's right. This thing should be amended out. Okay, it doesn't work either. I think there's some display issue somewhere, somehow. It should be like this. Perhaps there's some new bug in the rendering system. But this should work. I don't know why it's not working today. But anyway, this is basically the idea. Kind of awkward that it doesn't work for the new processing for. But basically, what you are trying to see is that your location, x plus y times width, and then you want to see the distance between x, y, and mouse x and mouse y. And you want to see if the distance is smaller than 50, then pretty much you want to copy the original things to the new pixels array and you update that. I don't know why it's not working in processing 4 anymore, even though it's just such a easy task. And now it's sort of like, I don't know, doesn't make any sense. Um, Anyway, that's the idea. So one thing you probably notice is that, the way how we handle array for images in processing, where basically you sort of like turn everything into 1D, which is kind of awkward. Actually, in processing, you can do 2D array. So basically you can see something like that, or more, easily visualized in this way. You can actually do integer double brackets so that you can do a 2D array. But still, in processing, whenever you're working with images, it's 1D array flattened. The same idea where we do this reveal effects, you can also do a lot of like different manipulation. That and given what we just encounter, I hope this work. Maybe there's some update on processing that these things no longer work. I hope that's not the case. Let's see. Huh? Okay, nice. So this is just a very fun experiment where we just basically take a sakura.jpg and we wanna just show it as a pointillism. So there are some things we can do. So this point size is how big that thing is. Let's do 1 and let's see. Too small. 2. So basically now what you're seeing is that for this image, we load the image, and for each single pixel, we randomly pick one single pixel, and now we are showing each pixel as like as a sphere that of that size. So what we're seeing here is that now we get the point size as 2. So things are very slowly showing up. We can actually speed it up, say this. So n is like the number of points that we are showing at each single second, I think. So if we do point size 2, that basically just show the original image, basically, right? Because you take a small pixels and you show it right like a circle at the pixels. So it would be like this. But now, more interestingly, when you turn this point size larger and larger, let's make it faster. So now you have like 3. Now things would be more blurry-ish. And now you turn to 5. You see that there's some, like oil painting-ish effects. And now you do 10. Now it becomes, much more like pointillism. So basically this is like some of the funny way, interesting way to work on these. And it's always, interesting to just look at these animation. You can even do 50. Now everything becomes just like, very blurry. So you can definitely find a good, balance between the size of the points and the speed of how you show it. But basically, to implement this is kind of not so tricky. So you basically load the image, sakura.jpg JPEG, so that you get the image. Now you randomly, for integer I equals 0, I smaller than. So you basically do a lot of points for each single frame. You basically drag a random pixel. So random image the width, random image the height. So pick a random pixel. Now for that random pixel, you want to find the color of the pixels. So you can actually do something like this: red, image the pixels location, green, image the pixels location, blue, image the pixels location. So you get the red, green, and blue. And so now you can actually do that with the circle. So we want to get RGB because we want to set the transparency so that things can, stack on top of another. So you can do the blending of colors. And you basically draw the circle with the size, 20. So, the size could change the different shape of that. So, 1,000 points, 10,000 points, even more with point size 20, smaller point size, you get different size. Cool. So that's pretty much about images. You can work with images, do all sort of things. This is unfortunately not working. I don't know why. But this case, this is working. So basically you grab all the images, you grab all the pixels, you now don't show it as a pixels, you show it as a circle so that you create this effects. But that's sort of the idea of, working with images in processing. We can also do something with videos. Again, I hope it's still working the same way. Processing 3 to 4 seems like there's something changing unexpectedly. So working with movie, it's a little bit different from working with image, but it's sort of like working with sound, actually. So we talk about how you can, get a sound file and then you work with it. So this is sort of similar to how you work with video. So for video, again, now similar to the sound. So for image, you don't need to import an additional library because image is sort of like built-in. For video, you have to install the video library, and then you want to import the video library this way, just like you do imports processing the sound that, the star sign. Now you want to start initialize my movie. And this is how you initialize the movie object. So basically new movie this, comma, and this movie dot MOV. And then you just loop this movie again and again. And this is, this is a function. It will code whenever a new frame is available to read. So you have to do this so that the movie frame is being constantly read so that you can show it here. So now I would try it again to see whether the movie work. Hopefully works. Let me see what it is. Okay, on it. Low movie. That's it. Some movie anyway. Movie.mov. So this is something. So what's going on here is that you know this movie won't be updated. But whenever you have this movie event, so whenever there's a new frame for this movie to read, then you do m.read. So now once you do m.read, this my movie thing will have an image, a pixel array that's available for you to show. So this is how movie work in processing, where you are constantly reading an image from a video file and you update that to your movie object. Cool. You can do a lot of different things. Frame rate, start, stop, read, of course. You can also work with a capture class. So this capture class is different from the movie class. Capture class is for working with your webcam. So this will be fun. Let's see if I have a demo. Pretty much how you work with it is just like the same how you do it with load movie. Webcam capture. Cool. This one looks like it will work, but I hope it does. Oh, no. Okay, next time. So one thing funny about processing is that when you're using Zoom, your webcam will be occupied, so you cannot use the capture. We can see it next week. I'm gonna say I will bring my webcam here so that we can see. So whenever you have like two webcams, then one can be used for Zoom, one can be used for processing. But in this case, I would need another webcam. Cool. So let's skip this. You can also do mirroring. Let's skip this. So one of the interesting thing that we can show, but likely we also need webcam to show any of these, but we can just go over what we can do. So this deep vision library is a deep learning powered computer vision library that supports a bunch of things: object detection, object recognition, object segmentation, key point detection, depth estimation, style transfer, and super resolution. And all of these is better shown with the webcam, which I don't have right now, unless we just stop Zoom recording, I guess. But anyway, it can do a bunch of stuff that I would just showcase later. But I guess we can look at these on Wednesday. And now we should talk a little bit about midterm assignment because that will be due soon. So for midterm assignment, basically the idea is just build your own music visualizer. Again, instruction will be sent by emails and release on the course website. So this will be very open-ended. Do it whatever you like. Basically, the only requirement is just use what you've learned from the class and beyond. So the rubrics will be something like this, use two of the following concepts: loops and recursion, data structures, arrays, lists, dictionaries, whatever. And hopefully objects, even though people tend to avoid objects at any cost. Anyway, hopefully you get to experience some of these concepts. And the other 10 points would be clear documentation in code and also live demo in class next Wednesday. So definitely start thinking about it. Homework 4 will soon be due, so plan how you work on these. So here are some of the examples that might give you some idea. We've talked about, some of the basic things about amplitude, FFT, pitch detector, but you can do a lot of different things that just using these concepts. There's some more. I was just share the slides. You can take a look. So, some of these can actually be just implemented using like a sound, amplitude, pitch detection, or even the FFT to make it responsive to the audio that you have. Cool. Yet another example. This is very cool. But this is not very responsive, I feel like. It's more like you're generating the sound and the art at the same time. But I believe the speed is synchronized to the audio. Cool. We have another example, which is sort of the pointillism thing we talk about. So now the size just change.
What the hell is going on? The dust has only just begun to fall.
Cool. So these are like some of the examples. We pretty much cover most of these in class. But the idea is like how do you connect those, sound analysis, but also FFT or any things in the sound libraries with all the techniques we've covered in class. And also there's a bunch of generative arts that you can also think about how you can connect those to your midterm assignments. So here are some of the examples. This look very easy to implement, but actually it's crazy complex to implement it because you need some sine cosine to make it look smooth. It's actually synchronized to the breath sound. So this is a very nice channel if you want to learn more about creative coding. The dot is black. They have so many, cool stuff that's very, very hard to implement, even though they look easy. There's also all sort of like different, generative arts. Anyway, I won't put those. This is one of the.
Build a website
Oops. I think we've seen this. So we will likely need objects for these. You have to keep track of where they are for each single point that's running. Cool. I don't think I have time to show the rest. But that's basically the idea. I will share the slides. You can look into it. There's much more ideas, but basically open-ended. Do whatever you like. And we will have demo next Wednesday. So plan ahead. You probably need some more time before that. Cool. See you on Wednesday.